Hi guys, this is Math 148, section 13.3, and this is question number 15. And the question for this section reads, equations are given whose graph encloses a region. Find the area of the region. So they give us two functions, and we have y equals x cubed minus 1 and y equals x minus 1. And it says find the region to the right of the y-axis. Right of y-axis. Okay, so this is what we're saying. We have some equation, and I'm pretending like I am a student on a test, very nervous, and this is all I have. So you have some equation. Okay, this looks like a line. You don't know what the line looks like, so you just draw a line like this in your mind. And this is some other function. Let's say you think, I don't know what it looks like. But we want to find what is the region where the graphs overlap to the right of the y-axis. So everything on this side. Okay, this is the y-axis. So we want everything on this side. So the first thing to figure out is you want to find where the two graphs intersect. So there's some point down here where they intersect. So step number 1 is find the intersection points. Find intersection. How do you find the intersection? Well, you're going to set the two equations equal to each other. We want to know, when does x cubed minus 1 equal x minus 1? Okay, well, the ones, you can add 1 to both sides, right, and they would go away. So then we're left with x cubed. If we subtract x from the side, x cubed minus x equals 0. I'm going to factor it now. The way you can find these intersections is by factoring. Darn it all, nobody likes factoring, except I kind of like factoring, actually. Can be satisfying. So one thing I did here, very fancy, this is a perfect square. X squared minus 1 is x plus 1, x minus 1 equals 0. Aha! So the intersection points are at x equals negative 1, x equals 1, and x equals 0. Doesn't that look like an x equals 0? Is when all of this is 0. So we want the positive side. So we know we're going from 0 to, we want to find the region enclosed, from 0 to what? To what? We're going to pick positive 1. So we know that you have some graph that has a slope that goes up and some other fancy graph thing, and they intersect at 1. They are the same. So this is not, so they intersect at 1. So we want this whole positive area. So we have step number 2. So now we know we're going to take the integral, hello. We're going from 0 to 1, but now we have to figure out which graph is on top. So step number 2, which graph is on top? And by on top, I mean which graph is the taller graph. So if we had this one and then this one, we want to take graph number 1 minus the one on the bottom. So we have to decide which way to subtract the two graphs. So essentially you want to find out which graph is bigger. Which is bigger in the interval. Bigger on the interval 0 to 1. 0 to 1. Because that's the one that's going to be on top. So we're going to take top graph minus bottom graph. And that's 0. And that's 1, for example. So let's just pick a point in between. This is how you decide which one is bigger. You'd take some random point. The book picks 1/2. I'll pick 1/2 too. Why not? So you say at x equals 1/2, which one is bigger? Well, let's look at the y equals x cubed minus 1. So at that point you have 1/2 cubed minus 1, which is negative 7/8. Where did that come from? Because that's 1/8. So 1/8 minus 1, negative 7/8. Okay, and the y equals x minus 1 graph, at the point 1/2, we have 1/2 minus 1, which is negative 1/2. So technically, this one here is bigger. And you're thinking, what? Because negative 1/2, is here, minus 1/2, and then you'd have to go down a bit to get negative 7/8. Okay, so it tells us why we did this is this one is bigger. So you kind of look at this one, you go, okay, that's the top function. It's the one that's above the other one. So now we're going to take the integral, top function minus the bottom function from 0 to 1. Okay, let's do that in this, no, let's do that in this one. Okay, now we're really ready to roll. We're going from 0 to 1. Remember, 1 was that intersection point. I'm writing so small. Intersection. Are you impressed with my tiny writing? And we're taking the top function minus the bottom function. You wouldn't write this on a test unless you wanted to. 0 to 1. The top function, I said, was x minus 1 minus the bottom function, which is x cubed minus 1 dx. Yay! Now we just integrate. Step 3. Just take the integral. Take the definite integral. So, now you can forget about the regions and just like totally apply your math brain. My math brain isn't working. I heard that. Okay, you're gonna do it anyway. X minus 1, and we're gonna distribute this minus sign. Minus x cubed plus 1 dx. The minus 1's cancel. So this integral is now 0 to 1. X minus x cubed dx. I like that. This becomes the x, you add 1. Here, I'll integrate it now. Add 1. So that's x squared, and then 1 over 2. Integration. Minus, add 1. X to the 4th, and then 1 over 4. You could add the constant, but it's going to go away. And we're taking this, evaluating it from 0 to 1. So, this is nice. At x equals 1, I'm going to plug 1 in here. So I have 1/2 times 1 squared minus 1/4 times 1 to the 4th. Again, plus a constant if you want, but the constants are going to go away. Minus, so all that was x equals 1 minus 1/2 times 0 squared. You wouldn't probably write this part. I'm plugging in 0, right? All this is x equals 0 equals, okay, that part goes away. Again, the constants, it would have been plus a constant, minus a constant. Those go away, and we're left with 1/2, I'll choose blue, 1/2 here, minus 1/4 equals 1/4. Yay! That's the answer, 1/4. Okay, and here's a picture I want to show you. So what's kind of strange about this, I drew this graph for you guys, but I did this is the exact same problem. This is question number 15, but I intentionally didn't start with the graph because the problem doesn't start with the graph, so you might not have a graph. But notice that in this case, the line, do you see how that's on top? But they're both negative. So this whole area, this region, is essentially a negative value, so if you ended up with a negative area, it's probably because you were subtracting the wrong direction. So it's a little bit tricky, but you always want to find whichever function is on top, the top function, and this one was the bottom. And again, this blue line, that's y equals x minus 1, and this reddish line is y equals x cubed minus 1. Sort of a, kind of was like this thing. So that's how you do, and we were finding this area, and we said that was, have you forgotten? No, 1/4. And there's one last thing I want to cover in this section, and that is average values. So average value is, here's the definition, the average value of a continuous function on the interval is, here's the formula, 1 over b minus a, and then the integral over that. So you take the integral, this part, here, you find the integral, and then you essentially multiply it, or divide that integral by the width of the integral. So, for example, in this function, if we wanted to find the average value, average value, we would say, well, we know the integral from 0 to 1 of this region is equal to 1/4. So what's the average value? Well, we're going from 0 to 1, right? This is 0, and that's 1. So our average value is going to be equal to 1 divided by, you take this end point, the bigger end point, minus the little one, times the value of the integral, to be basically still 1/4. Here's another problem that shows this. Do you remember this guy? So here's our question number 35, and this question asks to find the average profit over this region. So the average profit over this region, I'm going to use white, is going to be, we're going to take the profit, which is, we're going from starting here, x0 going to x1. We want the red region because the profit is going to be where the revenue is bigger than the cost. So this is revenue and this is cost. So we're going to take the revenue function because it's on top minus the cost function. But to find the average profit, we have to take 1 over the length of the interval. So it's x1 minus x0. And that's actually how you have to leave this problem. That's the answer. So I think there's an average profit or average cost thing on your quiz, so you can look at that. And as always, let me know if you have any questions. And I believe that on the test I will give you a graph for these problems because I think the graph makes it much easier. Okay guys, good luck. Let me know when you get stuck.